Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Seashells by Jolly Rogers. And here are the rules. We have normal Sudoku rules apply, which means every cell in the grid must contain a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have yin yang, where we need to divide the entire grid into C cells and sand cells such that all C cells are orthogonally connected, all sand cells are orthogonally connected, and no 2x2 area is fully C or fully sand. So here's an example of a yin-yang shading that is valid because every cell, what does it mean for all C cells to be orthogonally connected? It means you can go from any C cell to any other C cell just by going through edges, all while staying within C cells, right? So for example, to get from here to here, you just have to go all the way here on edges through all C cells. Or from here to here, it's the same thing. And then these will be the sand cells. I guess we can make that orange or something. But sand cells are the same way, right? To get from the sand cell here to the sand cell here, it has to be able to go through just edges, all while staying within the sand cells. And then the final part of yin-yang, so this is typical yin-yang shading, and the final part of yin-yang shading is no 2x2 area is fully C or fully sand. So this would not be valid because we have a 2x2 area, actually two 2x2 areas here, which are all fully C. This would not be valid as a yin-yang shading because we have a 2x2 area here, which is all sand. And that's how yin-yang works. We have German whispers, where any two C cells which share an orthogonal edge must differ in value by at least 5. So for example, if this were say a 3, this would have to be an 8 or a 9, because the only digits which are 5 or more away from 3 are specifically 8 and 9 in normal Sudoku. So that's for all C cells that basically share an edge. We also have seashells, where seashells only appear in C cells. And their digit counts the total number of C cells seen in all its indicated directions combined, not including itself. So we have, so obviously the shading is incorrect because we have certain seashells here which are not in the sea, which they only appear in C cells. And for example, this one would count 1 here, 2, 3, 4, 5, 6, 7. So this would have to be a 7 if that were the case, right? Because it sees this direction, it sees that, and it sees these cells. And nota bene, note well, sand cells do not block its view. So that's the reason why it sees this cell here. Even though it sees past the sand cell here, it's not blocked by the sand cell here that's here. So it would see this for 7. It would see these. This would also be, it would see 1, 2, 3, 4 cells that are C cells. So therefore it would see that because it's not blocked by sand, right? And then finally, crabs. Digits joined by a crab must sum to 10. So for example, if this were say a 3, this would have to be a 7 to add up to 10. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, let's mark all C cells. C shells as C cells. This can only see up to 6. This can only see up to 7. So we know on C cells, you cannot have. That's interesting. So for yin yang shading, once you swap from, you can only swap twice the region that you have on yin yang shading. And the thing is, yeah, you can only swap twice on yin yang shading. So the thing is, if you when you swap from blue to orange, I guess here, you can't swap back, right? You can't have this be orange then, and then try to swap this to blue. And the reason why this doesn't work is because try to connect orthogonally the orange cells and the blue cells. The problem is, if you try to orthogonally connect the orange cells, you'll necessarily break the blue cells into two separate regions, even though it has to be one full region. And if you try connecting the blue cells together, you have the same problem, right? You'll break the orange region into two separate regions. So that's the reason why you can only swap once and then swap again. Well, we know, again, on a C cells, you can only each C cell that shares an edge with another C cell must have a difference of at least 5. Because of that, 5 can never be on a C cell because it would be, well, subtract 5 or more from 5, you get 0 or less, which is not normal, so it's normal Sudoku digit. If you add 5 or more to 5, you get 10, which is not a digit. So that's the reason why 5 can never be on a C cell, because every C cell is orthogonally connected again, or must be orthogonally connected to the group. So there's at least one cell that you're going to have that has to be, that cannot be in a C cell. Because of that, there's not going to be any columns or rows, which is completely C. And because of that, and because you can only swap shadings twice total, that means we know you could have the largest the blue region could be on the edge is this. Because you know you have to swap some either, well, I guess it could be this way too. So you could go this way or this way. But we know you can't have a full row or a full column, which is all blue. And because of that, you know that the blue is going to be at most this way or at most this way. Because it can only swap twice, right? So you can swap to the orange here and swap to the orange here, or swap to the orange here and swap to the orange here, with those being 5. Right? So you're guaranteed that this cannot be the blue shading. It has to be the orange shading, the sand. So this is 1 through 6 without the 5. This is 1 through 7 without the 5. 1, 2, 3, 4, 5, 6, 7 without the 5. This can be up to 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that could be up to 9. And this could be up to 8. So it could be 8 at most. This could be 9 at most. This can be only 8 at most. Right? 1, 2, 3, 4, 5, 6, 7, 8. And this can only be 8 at most. 1, 2, 3, 4, 5, 6, 7, 8. So this could be 8 at most, 8 at most, 8 at most here. Interesting. So since we know, okay, so also another thing about German whisper lines, or as I like to call them, whisper 5 lines, is you'll always alternate between low and high digits. And on whenever there are two whisper 5 cells next to each other, right? So the thing is, to get to this cell, we know, okay, so then this is going to have to be two different sets, right? For the C cells. We're going to mark this one as pink and this one as yellow. So whichever one matches these essentially can be pink or yellow, right? One thing we know about this is this cannot be a full 8. If it were a full 8, then all of these would be blue. And then the orange would not be able to connect. Then there has to be some oranges here because there's a 2x2 box here. So this cannot be the full 8. It has to be at most 7 then here. But, okay, so like I was saying, you always alternate between low and high digits on a Whisper 5 set. Well, to connect, you have to connect orthogonally to each of the C cells that are already here. So you're going to be alternating depending on what it is. So this would be yellow, this would be pink, yellow, pink, yellow. So this has to be size yellow also. From here to here, yellow, pink, yellow, pink. So this is size pink. And like if you try to do it any other way, since you always have to be orthogonally connected, it will always alternate to that set, right? So pink, yellow, pink, yellow, pink, yellow, pink, right? Pink, yellow, pink, yellow, pink, yellow, pink. So this is pink. And then pink, yellow, pink, yellow. So this is size yellow. So the yellows are going to be the same set, which is either 1 through 4 or 6 through 9, which is the low or the high. Because you'll always alternate between low digits and high digits on a Whisper 5 line. Because you have the digits 1 through 4, what digits can be next to it? 4 can be next to 9, 3 can be next to 8 or 9, 2 can be next to 7, 8, or 9, and 1 has to be next to 6 through 9, all of which are high digits. And it's the same thing for 6 through 9. What digits can be next to those? 6 can be next to 1, 7 can be next to 1 or 2, 8 can be next to 1, 2, or 3, and 9 can be next to 1 through 4, which are all low digits. So you'll always alternate between low and high digits. And it's the same thing here. So then for yellow must be the same set, and pink has to be the same set. Interesting. If this is 6, that means all of these are blue. Right? These would all have to be the same blue, if that's the case. If this was 6. So that's only if yellows are high. If yellows are high, these are all blue. Which means orange has to at least start from here. And it has to connect to the rest of the orange. So therefore this would be all orange. And this one could be orange. We just don't know. This is blue, so that would be orange here. This would be orange here. The orange has to connect, so it has to go out that way. This is blue. What would that tell us? This would have to be high dit 2. And since this is 6, this is orange, this is orange. So that's 1 blue there. So it'd have to be 2, 3, 4, 5, 6. So that would all have to be blue. Interesting. And the interesting thing, okay, so then this would have to be high. 1, 2, 3, 4. Oh, wait, it's this way. 1, 2. That's possible then. So this would be 6 in that case. This would be 6. It has to be next to a 1. And then you have a contradiction. So this is the problem that way. So that means the yellows have to be lows and the pinks have to be highs. So the yellows are low and the pinks are high. So this has to be 6 or 7 here. This can't be 9. This is 1 through 4 here. This is 1 through 4 here. This is not 8, it's 1 through 4. This has to be 6 or 7, and this is 6, 7, or 8 here. Again, it can't be a full 8 here, because if it's the full 8, this would be C cells all here, and that would block the necessarily sand cells here. So at least 6 out of these 7 are C cells. Hmm. What else do we have? The interesting aspect, so say this was 6. I guess that's possible. 6 then 1, and then these are all sand cells. So this can't be... This has to be next to 6 or 7, so this has to be 1 or 2 here. So there's only 1 or 2 C cells here. That's interesting. There has to be 6 or 7 C cells this way. And... What does that mean? I don't know. They would all have to be red, but it doesn't really matter right now. Okay, so let's make the reds essentially blue. We can color them differently in... Well, we don't really need to color them different. Well, it's always helpful. We can color them differently later when we figure out the sea and the sands. Well, we might have to anyways, though. Now let's just keep it as red. Blue and red are the same, are C cells, and the sand cells are orange. Interesting. If this is 6, that forces this to be 1. If this is 7, then it could be 1 or 2. Can you have 7 here is kind of the question, right? Well, if you have 7 here, you can't have both ends be blue. If you have both ends be blue, again, you can only change once. So then you would have to go like that, right? Oh, this can't be 6. If this is... Because... Well, it could be 6. It could be 6 going that way, right? Or 6, like, going some weird that way. Huh. Can it be 7? 6 and 7 are both interesting, right? Oh, that's interesting. So if it goes down, say it connects this way, in some sense. then this has to be part of the blue, so it must connect to blue there. Right? And this would necessarily be 2, so that would have to be 7. If you have 7 going this way, so the question is, can this ever be sand, is really the question. So if we have sand there, you can't have both of these be C, because again, they would have to connect, because you can't change, you can only change twice, and you have to change once this way and once that way if both of these are C. So then this would have to be 6 if this is the case, if this is sand. And then one of these two would be C. The rest of these would, so this would have to be C. And this would obviously be 1. This could not be 1 then. It would see 1 here, 0 there. So it could be that that's C and this is sand. That's certainly possible. Seems feasible. Um, Can it be C over here? It would have to be red. Or this is red. Oh, that's interesting. So you'd have red and red here. Oh, you'd have to have a 5, right? So this would be the 5. Well, no, 5 could be one of... Yeah, 5 could also be the other non-digit here. This is between 2 unique digits on a whisper 5 setting, so it's 2 or 3. 7, 8, 9, 7, 8, 9. This could be 2, 3, or 4. If we have 7, that's interesting. If we have 7 no matter what, then these, again, all of these are C, and the other one has to be C also. Oh, that's another reason why it can't be all C in a column, is because you have to have a 5 there somewhere, right? So these would be C. C. And so this would have to be 1 and 2. This is 3 because it's next to 2 unique digits on a whisper 5 line. So that's 3, 8, 9, 8, 9, and this would be 4. So this would be 4, this would be 9, this would be 8. You cannot have the 6 be here. So if it's 7, it has to be going this way. So therefore, these must connect. So then this would be blue, red, blue, red, blue. So it has to connect that way. This sees 2 cells. So this would be 2. That works. 1, 2. This would be 6. This would have to be 7. So all of these would have to be C cells. So those would be 7. And they have to be red because it would be red, blue, red, blue, red, blue, red, blue, red, right? Interesting. So this would be sand. Ah, and then this cannot connect. Okay, so there we go. So we've proven this cannot be 7. It has to be a 6. Because the way that that works is that if it's 7, one of the ends cannot be on the C. So that means all of these are C cells. So this has 7 is next to 1 and 2. There has to be a C cell here. This sees 2 of them here. So therefore this has to be 2, which forces that to be 7, which forces all of these to be C cells. And because all of these are C cells, it will block the sand from connecting orthogonally here, because there has to be sand here. So that's why that does not work. So we know then this has to be 6. So since this is 6, one out of the 2 ends cannot be C cells, because again, you would have to connect here, and then the problem is that there's a 5 somewhere in column 9, and that can't be next to, or that can't share an edge with another C cell as a 5, which would make that the C cells are not orthogonally connected. So one of the ends is not a C cell, and one of these cells is not a C cell, because 6 cannot be next to 2 unique digits on a whisper 5 line, and it would have to be if both of these were C cells. So that means the rest are all C cells. We know this is a C cell, C cell, C cell, and C cell. One of these two is, and it's a 1. So we know there's a guaranteed 1 in one of these. This can't be 1. It's between 2 unique digits. 2, 3, 7, 8, 9, 7, 8, 9. And this could be 2, 3, or 4. One of these is, and it's a high digit. Guaranteed. Interesting. Okay, this can't be 7 either. If this is 7, well, no, it could exit out this way. No, well, yeah, it could exit out that way, so it still could be 7 here. Okay, one of these digits is a high digit, because again, you have to alternate between lows and highs on the whisper 5 lines, and however you get to it, whether it's here, like high, low, high, that would always be high, and this would always be high, low, high, right? So that means the rest of the row or column cannot be high. So these are 1 through 5, because we have 2 highs here and a third high here, and then one of these is high. So this is 1 through 5. This cannot be a full 8. If it's in full 8, the problem is that this would block off the sand from being orthogonally connected. So this cannot be 8, it's 6 or 7. This could technically be 7. Yeah. Actually, no, it cannot. Say this was a full 7. So the problem is this would have to, okay, we can't have this be a C cell, because then we have a 2 by 2 area which has 3 C cells, so then this would be sand, but the sand can't orthogonally connect. So since this can't be a C cell, this would have to be a C cell, but then all the C cells would connect this way, because you can only switch twice on the edges. And you would guarantee a 5 in a C cell, which is not possible. So this cannot be 7. This has to be 6. So this is 6, which makes this 1. That means this can't be 1 here, so this must connect this way to the 1. So this must be C cell, and it has to be the 1. This is not C cell, this is sand, then. Okay, so this can't be 1. Okay, this is 2, 3, 4, 5. So either this is C or this is C. We don't know which. 6 is here, 6 is here. 6 has to be one of these three. This is 1. Say this was C. Then, okay, these would all be C. That's interesting. These would have to be sand and then connect. Does that work? Obviously, so this could not be both sand. So to connect it has to be C there. This, one of these two has to be sand. At least. How would that work? Okay, so let's also do it so that we have the coloring. These would be blue. This would have to be all red. These would all be orange. I don't think this could be 7 really either. But this would be problematic because one of these two digits would have to be 6, and they would both be next to two unique digits. This is next to those two unique digits. This is next to those two unique digits. So that's not going to work. So then this cannot be C. This is sand. This has to be C. Interesting. So this must connect this way. So this is low, high, low, high. That means you're gonna have to not be part of 5. 5 is gonna have to be here somewhere. So therefore you have to switch to sand here. 5 is gonna be here somewhere, so you have to switch to sand there. So this must all be sand. Since this is all sand, this must be C here. It is a high. Okay. This is a 2 by 2 area, which is all C, so this must be sand. This could connect technically. That could be 6, 1. 1 cannot be any of these. So where's the 1 in this box 9? And this has to be 7, 8, 9. 7, 8, 9, 7, 8, 9. So this is 2 through 5. This can't be 1. It's 2, 3, or 4. It cannot be 4. It's next to 2 unique digits on a Whisper 5 line. This could be 1, 2, or 3. So we have 2 sand here. These are all sand. 6 cannot be next to another digit on the Whisper 5 line. So these must be sand. Or the C cells, right? So this is sand. That forces this to be a C cell. Because this is 6 and 1. At least one of these digits has to be a sand, because you can't have all C here. Same with these, I guess. So say... One has to be one of these two, which means one has to be one of those 3. Ah, this already cannot see here. So say we try to make this 7. It would go all the way here. How would that work? Would that work is the question, really. Red, blue, blue, red, blue, red, blue. Okay, so that would force this to be sand, this to be sand, this to be sand, and this to be sand. Ah, that doesn't work. Well, no, it could. This would be sand, this would has to connect. Hmm. Sand, sand, sand. This has to be sand because this 2x2 area has 3 C's in it. One of these is sand, one of these is C. That's fine. So this looks, right now it still seems okay. These are next to 2 unique digits in Whisper 5, so this can't be 6. This becomes 7, 8, 9. Huh. So that does seem pretty doable. This is next to 1 or 2. Next to 1 or 2. This is 1, 2, or 3. Cannot be... So this would have to be 4 if that's the case. Because we'd have a 2, 3, 2, 3 pair in that box, which eliminates 2 and 3 in the rest of the box. Because this is next to 2 unique digits on a Whisper 5 line. So 4 would have to be next to 2 unique digits here, and that's impossible. So, yeah, cannot be 7. It has to be 6 here also. So this has to be 6 also. Interesting. So this can't be 6 here. This can't be 6, 4. It could be 1, 9. If this is 1 and this is 9, 2, 8. Or 3, 7 to add up to 10. Hmm. Hmm. If this was 4, that would mean this would not... This would have to be 9. This wouldn't be a sand. You could have a 9 there, potentially, so it could be red there. Well, there's definitely a sand somewhere here. Or here. I don't know how they connect, though. This is 6. It cannot be next to 2 unique digits on a Whisper 5 line, so it can't be both of these. Could be both of these, though. That would be possible. Can't be both of these, either. Can you do the full set here? I think the answer to that is no, right? So let's try that. If we tried the full set here, blue, red, actually just even this, red and blue. Because this is blue, this is C, it must connect to all the C because you can only switch once this way and switch once that way. So then this would connect, and then this would have to be a 2-3 pair. Right, so one of these two cannot be C. Because if both of them are C, then it forces this situation, which basically has to connect to here, because you can only swap twice on a border for yin-yang. And it would swap once here, swap once here. So you can't swap again here. So this has to be C. Because this is C, this is next to 2 unique digits on a Whisper 5 line. This is next to 2 unique digits on a Whisper 5 line. This is next to 2 unique digits on a Whisper 5 line, and none of them could be 4, even though we have to have a 4 there. So we know all of these are C. So this is blue, this is red, we have blue here, and this is red. One of these two is not. So this is next to a 1 in both areas. This points to at least 2 here. And it can't be a 1 because of the 1 there. This can't be 1 and 9 then. This has to be 7, 8, 9 next to the 1. This is 7, 8, 9 next to the 1 and 2 or 3. Because this connects this way, this must be sand. And this must be sand here because of the 2x2 areas. What? Okay, so this can never be C. If this was C, you're guaranteeing this is sand. Oh, that's not true. This could be 4 then. Okay. 2, 3. Okay. Hmm. This has to connect somewhere to the sand here. One of these is C, one of these is sand. That's interesting. Cannot be both sand. So it could be sand, sand, and then this is... Oh, this is sand here because of the 2x2 area here. One of these is sand, one of these is C. We're not sure which is which. Okay. 6 can't be here, so 6 is one of these 3. Hmm. 6 can't be here or here, so 6 is one of these 4. Okay. These cannot be C because they would have to be 1 to be next to a 6. So these are both sand. Also on a yin-yang shading, if you anytime you have a diagonal which is the same set, you cannot have the other diagonal be obviously the same set because that's a 2x2 area that's all the same set, and you can't have a diagonal be different set, the other set, because if you have a different set here, how do you orthogonally connect that to this part here without breaking the other diagonal into 2 regions? You can't. So this must be sand also. Interesting. One of these two is sand, one of these yeah, and the other one has to be C, right? 1, 2, 3, 4, 5. We need another one here. So this is a sand C mixed. We're using green for the ones where we don't know the shading. We don't know if it's blue or red, right? Okay. Let's just do this. What happens if this is the C? If this is C, this is obviously sand. This has to be sand. This has to be sand here because of the 2x2 areas. So this is all sand here. Obviously, this would be sand, and then this would be C. That seems to work okay. Hmm. Huh. Okay, so that's not helpful. Hmm. What happens if this is C? And this is sand. This must connect this way. This obviously can't be 4. So this would have to be a 4 here. This would be 9. This would have to be 3, because then this can't be 3 anymore, because if it were 3, it'd be next to 8 and 9, which was not possible because of this 9. So this would be 3 here, 8, 2, 7, and this would be 9 here. 9 could not be here, 9 could not be here. This is the 3 forces this to be a 2 here. This can't be 2. This can't be 4, so this would be 3, 8, 7. So that seems fine. This can't be high, because so this would be sand. Since this is sand, this would have to be sand here. Oh, that's interesting. I think either way, we've gotten that this is sand, right? So we tried this being C, and that forces all of these 3 to be sand. And we looked at the other way, too, where this was C. That forces this to be sand. This has to be sand. This is sand. And since this is sand, all of this has to be sand. And we figured out this has to be sand either way, in both scenarios. Right? If we try this as a C, this has to connect that way. This cannot be 4. So this has to be 4 here. That's 4 and 9. 3, 8, 2, 7. This has to be 1 then. That's 9. And this can't be C. It has to be sand, because otherwise it'd be next to a 4. This is sand, obviously, and both of these are sand, so that forces this to be sand there. So yeah, we come into the same scenario either way. So either way, we know these 4 are sand, and this must be C. So it's next. This is next to 2 unique digits on a Whisper 5 line, so it cannot be 4. It's 2, 3 as a pair, which eliminates 2, 3 in the rest of the column. This is next to 7, 8, or 9. This digit is not next to a 1 on the Whisper 5 line, so this has to be 7, 8, or 9 also, which means we cannot have a 7, 8, 9 remaining in row 2. That means the only high left would be a 6, but it can't be next to a 1. Because it has to be one of these 2, right? Well, okay. This can't be high, essentially, because that would be next to a 2 or 3 on a Whisper 5 line, so that's impossible. So this has to be a low, and this connects this way to be sand. So we've got the yin-yang shading. Let's make it green, I guess. We know these are borders. This is a border here. We have a border, oops, this side. This is a border this way, border here, border here, border here, and border here. It's kind of hard to see the green, but one of these 2 obviously is shaded, or C. The other one is sand. These add up to 10. It has to be 2, 8, 3, 7, or 4, 6. Okay. These two are connected, so this must be sand here. Because again, like I said, so this sees 1 and 2 right now. That are C. This sees 1, 2 right now. If it's 4, it cannot be 4. If we try to have this as 4, we have 1, 2 here, and it would have to be 3, 4 here. But then this would be next to, well, it could be actually 4, and this would be 9. Oh no, it'd be next to 2 unique digits on a Whisper 5 line, which is impossible. So this can't be 4. So this is 2 or 3. Okay. um. This could be a 1. This could be a 1. We have a 1 guaranteed to be one of those two. 1 has to be one of these two. One cannot be here or here, so 1's one of these 3. This can't be 1 here. So this, okay, this has 1. That means the rest of these are all sand. Okay, so that's probably one we should have figured out. One of these two has to be C. I guess it could connect this. No, it can't. If it's C, it has to connect this way. And one of these is guaranteed to be C. So if it's this one, it connects that way. So this is blue. This is red. And we know the 6 has to be one of these. It cannot be here. It has to be on the high. So this must be 6, which forces this to be 1. So this cannot be 1 here. That forces 1 to be here. And 6 cannot be next to another digit on a Whisper 5 line. So this is sand here. And therefore this connects as sand because you can only swap twice in on the edges. This is 6, that's 1, 6 and 1. Where's 6? This can't be 6 anymore, so this can't be 4. 6 has to be one of these 3 digits here. This could be connected, so that's fine. Okay, so this sees 1, 2, 3 at least. So this is not 2, it's 3 or 4. This must go out to connect, so that's... Oh, and this is not C for the 6, so these both must be C. And therefore this is a diagonal. This is the other type, so this must be the C type. This is then 7, 8, 9. We have all the highs accounted for in box 5, so this cannot be a high, it's sand. So we have boundary here, boundary here, boundary here. This has to connect to other sand, so this must be sand here. So that's boundary there. This is a 2x2 area here, which is 3 sands, so this must be C, and it's the red. We have a 2x2 area here that is all C, so this must be sand. This must connect this way, so it has to be there. This cannot be a 6. So that connects there, that connects there, to connect there. This is 2, 3. It cannot be next. It's next to 2 unique digits on a Whisper 5 line. This is next to 2 unique digits on a Whisper 5 line. So these are both 2 and 3, which means this can't be 3. This is 4, which makes this 9. So this cannot be C. It has to be sand, which means that's sand to connect. Therefore, this is C here, because of the 2 by 2 area, that's all sand. This is border here. We have a border here. This is 7, 8, or 9. This is 7 or 8 because it cannot be 6 or 9. This is 7 or 8. We have a 7, 8, 7, 8 pair in row 7, which eliminates 7, 8 in the rest of the row. So this is 2, 3 with 7, 8. This has to be 2 through 5, 2 through 5, 2 through 5 in the rest of row 7. This is 2, 3, or 4. This has to be 7, 8, or 9. So this must see 4. Okay. So then either okay, this is a 2 by 2 area, that's all C, so this cannot be C. This is sand. So this is done there. This sees 1, 2 C cells. It sees 3 here. This must be the 4th. So this is connected there. This is a 2 by 2 area that has all C. So this must be sand there. Okay. These are borders. These are borders. Now just connect these. So if this is 3, one of these, so okay. Remaining digits in column 4 are 2 through 5. We know where is 9. 9 has to be one of these two here. Which means where is 9 in row 9? It has to be, oh, this is, yes. This is not 9. This is a 7, 8 pair. The only digit which can be next to 7 or 8, 7 and 8 out of 2 and 3 is 2. So this is 2, this is 3. 3 has to be next to 8 and 9 on a Whisper 5 line, therefore this is 7. No 7 here, no 7 here. This is a 4, 5 pair here, which eliminates 4, 5 in the rest of row 8. This can't be 4, 5. This can't be 7 or 8. Where is the other 7 or 8 in row 8? It has to be here. So this is 7, 8, and this becomes 9 and 2 as a possibility. This 2, 9 pair eliminates 2 and 9 in the rest of the box. So this can't be 2. This is 3, which makes this 7, which makes this 8. And then this has to be a 4, 5 pair. This is 7, which forces this to be 8, which forces this to be 7. 7 can only be next to 2 out of 2 or 3 on a Whisper 5 line. So this is 2, this is 3, this must be 9, and this must be 8 to be next to the 3. This can't be 3, obviously. This can't be 8 or 9. It's 7. 7 can only be next to 2 on a Whisper 5 line. So this must be 3, which must be next to 8 or 9 on a Whisper 5 line. This can't be 3. This Can't be 7. This is an 8-9 pair. This is an 8-9 pair. Interesting. This 9 eliminates 9 here, so this is 8, which makes this 9, which makes this 8, which makes that 9. Okay. This cannot be 8 here. This can't be 8 here. We have a 7-9 pair in column 2. 7 eliminates 7 here, so this is 9, which makes this 7, which makes this 9. Okay. Seven can only be next to 2 on a Whisper 5 line out of 2 and 3. So this is 2, which means we see all the C cells here in this direction. So these cannot be C cells. C cells, they're sand cells. So this must connect this way. So this is red and this is blue. This red has to be 8. It's the only digit left. This is 1 or 3. This can't be 3 here. No 3 here. 2, 4, 5. This can't be 2. Where's a 2 in row 7? It has to be there. So we have the C cells and the sand cells. Though, ironically, the C cells are much less than the sand cells. So this cannot be 2, 8. This can't be 3, so this can't be 7 there. This could be 2 or 4. This can't be 3 because of 3 in the column. Okay, now the rest is probably Sudoku. 9 eliminates 9 here, so this is 2, which makes this 9. 2 eliminates 2 here, so it's 4, which makes this 7 and 3 to add up to 10. This can't be 4 here because of 4 in the box. We have 2, 4, 5 remaining in box 5. This can't be 2 or 4, so this must be 5, which makes this 4, which makes this 5, which means this can't be 5 either. This is 2. This can't be 2 or 5. It's 4, which forces this to be 2. Remaining digits in row 6 are 6 and 7, but we don't have anything there that distinguishes. We should have a lot of 2s. We do. We have 8 2s. We know where the last 2 has to be. It has to be there. So this is 2. Where's the 1 now in column 9? Can't be here because of 1 in the box, or here, because that's filled out. So 1 has to be here, which eliminates 1s here. So this must be 1 here, which eliminates 1 here. Where's the 1 in row 5? Can't be here because 1's in the boxes. Can't be here or here because 1's in the column, so it must be here. So that's 1. Okay. We should have a lot of 1s. We have all the 1s. Okay. 3s. 3 cannot be here or here in box 6. It has to be here. We don't have any other restrictions, though, so 3s is not helpful right now. 4. 4 has to be... okay. This is probably not the best way of going about it, I don't think. 9s? Yeah, it's not the best way. Let's go row by row or column by column, whichever has the most filled in. So this is 5 or 6 in row 2. This can't be 5 because of 5 in the column, so that's 6, which makes this 5. We now have 8 digits in column 6, so this must be an 8. We have 8 digits in column 5, so this must be 5, which makes this 4, which makes this 5, which makes that 4. 4 eliminates 4 here, so it's 5. Now we're missing 2 digits in column 2. It's 3 and 4. 4 can't be here because 4 in the row, so this is 3. This is 4. 7 digits in row... 7 digits? 6 digits. I thought there was another 7 digits. Maybe not. No. Okay. 6 digits in row 1. 6, 7, and 9. 7 can't be either of these, so 7 has to be here. That makes this not 7, so it's 6, which makes this 7. This can't be 6 anymore. We have 6 and 9 remaining in column 1. Sorry, row 1. Row 4, we are missing 3, 4, and 5. 3 and 4 cannot be here, so this is 5. Therefore, this becomes a 3-4 pair here. In box 3, we have 7 digits. Also in box 8, we have 8 digits, so this is the last digit, which is a 7. That leaves this digit as a 6 and this digit as a 5. Remaining digits in row 3 then are 8 and 4. This can't be 8 because of 8 in the column, so this is 4. That's 8. 4 eliminates 4 here, so that's 3 and 4. Remaining digits in row 5 are 6 and 5. 5 can't be here because of 5 in the column, so this is 6. That's 5. 6 eliminates 6 here, so it's 9 and 6. That leaves this digit as a 9 and this digit as a 3. And that's the solution. Yeah, pretty cool. Nice little logic behind the yin-yang and how it connects. Right? Though, interestingly enough, there's more sand cells than sea cells. Even though the sea tends to be bigger than the sand. But, it makes sense, because he has to have the seashells. Though, actually, seashells could actually be on... You find a lot of seashells on the sand. I don't know. It's it's just something that's a quirk, I guess you could say. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.